In order to test possible strategies for the control of an extra limb, we developed a platform integrating a virtual environment and a robotic exoskeleton that allows for immersive simulation. During this simulation, users see an avatar in a first-person perspective, endowed with an extra limb, which we designed as symmetrical, so possessing 4 digits and 2 thumbs in order to avoid any association with a left or a right arm. In particular, we use this environment to test our gaze respiration-based control interface. And as a first step, we decided to assess its actual feasibility for effective augmentation, so assessing the possibility of still speaking and gazing.
Our goal is to allow healthy people to control an extra arm as naturally as the real natural arms. And what we did in our study was to show that using breathing and gaze, it is possible for healthy people to quickly learn to control an extra arm while also controlling the natural ones.
So we are also investigating other approaches to control this extra limb, for example, using vestigial muscles. So these muscles that we have in our body, but through evolution we have lost their functionality. We have found that through a few days of training, people could use these auricular muscles, which are this muscle we have behind the ears, to control this extra limb while still using their natural arms and still speaking and looking around.
The main motivation is to understand the nervous system. Because if you challenge the brain to do something which is completely new, you will understand whether the brain is able to do that and how you can facilitate this learning. And then you can transfer this also to other applications, in particular, for example, for assistive devices with people with disability, rehabilitation after stroke, and these kind of things. So the motivation is, can we boost the plasticity in the brain to allow the brain to learn to do something completely new and unseen before?